Seminar on data scraping, and thank you very much for Alex and Paul for joining and coming in. So basically the idea is that Alex is from Import.io. You have an interesting user success analyst is basically...
An evangelist now.
Evangelist.
I changed at the start of the year, so
Okay.
sorry I should get you guys in touch. But yeah, I travel about talking about import basically. It's quite a glamorous job. I'm sort of a rock star of data. I go on tour a lot and I do a lot of shows and talks, but without the bad stuff that rock stars do.
Okay. So you get, also, hopefully you get also the other good stuff that rock stars do. And then basically, so the thing is, Alex is going to talk about 30 minutes about Import.io, the software, and present it and demo it. And then we have Paul from the Department of Methodology. And I actually realized it's quite interesting because your focus is designing tools, like basically computer-mediated tools for people who are non-techies and so on. Is that?
Kind of, yeah. I'm a research officer on a project called Quantest. It's an ERC project at the Department of Methodology. So it's to develop software to make it easy to analyze texts quantitatively.
Yeah.
So using R, but designed to be as user-friendly as possible for people who might not know much R.
Okay, that's actually quite good because I think as at least in the information systems group, some people have sometimes said that they study information systems, but when it comes to technology and so on, they're completely lost. Definitely welcome aspect. But anyway, yeah, I think we are good to go. So
Cool.
Yeah.
Thank you very much. Thanks for the introduction, Kari. That's really good. I don't usually get an introduction, so I don't know what to say now. Usually I'm Alex, but it's already been done. So I think what we'll do, because I've only got half an hour, I want it to be quite sort of hands-on and look at what my talk can do, as opposed to talk about data scraping for half an hour and bore you guys to death. But I would like to take the first sort of 2 or 3 minutes or so just to show you a quick slideshow of why we do data extraction, an overview of the product, and it should get your mind thinking. So I hope you guys like the colour blue because my presentation is all blue for some reason. So what is import? Well, our mission is to machine read the web. So this makes the whole web structured, and it makes it available for everyone to use and manipulate and to analyse. We have a very easy to use tool. It's point and click. You don't need to know any coding or anything like that, which is a good thing. Otherwise, I definitely wouldn't be here because I don't really know how to code that well. You just have to map the data on a page, and we've got some pretty complex algorithms which we're going to start with, and it will turn it into structured data. We recently launched a tool which means that you don't actually have to map any of the data on the web page. We've got some algorithms that can go and make an educated guess into where the data is. Everything's available through an API, so when it's put simply, when it changes on the website, it changes in your database, your API as well. Again, we'll be talking about this in a little bit more detail with the demo. For those sort of more technical people of you, we've got the ability to make custom crawlers, which is what we're doing today. Auto extraction, which is the algorithmic side of things, which allow you to get data from a website without inputting anything. We have the opportunity to get stuff from behind logins, which is quite a popular feature. So like your Amazon wishlist and your eBay stuff. It's all available on the cloud, so no matter where in the world you are, so long as you have internet connection, you can get your data. So none of it is stored on your laptop. And we have a wide range of integration options. Again, we're probably not going to touch on that too much. I'm going to show you guys the integrate page. But we can integrate with a whole host of client libraries, Python, HTML, JavaScript, and so on and so forth. So put simply, we're just trying to structure the web. So we're trying to take it from the left screenshot, which is just a web page, to the right screenshot, which is a nice structured table, allowing us to analyse and manipulate the data. So, as I said, it allows us to analyse stuff, it allows us to visualise stuff. We're doing lots of integration with a lot of visualisation companies, such as Tableau, quite a big visualisation company. Plotly as well, we have an integration straight into Plotly, as well as some other ones such as Silk and Infogram and stuff. And finally, it's a lot easier than copy and paste. Though I've been trying to tell that to my mum for ages, and she just doesn't believe me at all. I just say, just use the tool, but she likes to copy and paste. So we've got 4 tools. We've got a magic tool, which is our magic algorithms. The name is sort of pending. We are probably going to change that name because we know that magic isn't the best. We have an extractor tool that allows you to take data out of a single page. A crawler tool is sort of like an exploratory tool. It sort of crawls around whole websites and pulls in hundreds of thousands of pages quite quickly, even if you don't know the URLs of those pages. And then we have a connector tool that we're going to try and get onto today, but I know time is a little bit pending. A connector tool allows you to use page interactions such as search, page clicks, and it'll extract the resulting data. So for instance, if you want to search Tesco's for the price of biscuits, and then beer, and then wine, and then cheese, you don't need to go to the Tesco website to do that all the time. You can just pop it into your data set and it will go get you all those prices. Again, I'll show you the data set at least at the end so it gives you an idea of what that's about. We have a custom-built web browser. We are sort of migrating away from a downloadable web browser. We're looking to do everything in Chrome nowadays, but for now we have this custom-built desktop app. And as I said, everything's completely free, obviously, as the slide says, and everything's available over the API, so it's very much real-time data. And there's a picture of a cat, which just snuck in from my last presentation. I don't know how that happened. So what we're going to do is we're going to look at sort of 3 different use cases. We're going to look at this lovely table here, and we're going to extract all of this table with a single click. We're then going to look at some custom extraction. So let's say we don't want everything in this table. Let's say we only want a few points of data. We're going to get that from the football table, which is what you saw earlier on. We're not just going to be watching football today. And then finally, I'm going to show you the crawler tool, and we're going to try and extract all the prices for all of the products on ASOS as well. So let's begin. To start with, we're going to look at our magic algorithm. So usually you'd have to learn Python back in the day, and I recently went to a class about using Python to get data from a single web page, and I got a headache and nearly passed out. It was very, very hard, and I could never have done it. With import, you just need to copy that URL, Control-C, and then head over to import.io, which is our web page. And because we've developed our algorithms pretty well, you can just pop that URL into the box there and click Get Data. And if we give it a few seconds, you'll see that we've got all of this data structured into a nice, easy to read table. So we've got all of the data that we need. We can then download this as a CSV or HTML file, Excel or JSON file. But more importantly, we can get an API. So what this does is it builds an API to that web page. What this allows us to do, obviously, when the data changes on the web page, we just need to hit that query button and we'll get the most up-to-date data in our data set. So that's why we build APIs to this page. This is why we don't copy and paste, obviously. Copy and paste is static. Building an API to a web page is dynamic, it's real time. So whenever it changes, it will change in your data set as well. So that's the simplest of our tools, and you can see it takes about 2 minutes to get data out of a website using that. But you can see here that we've got a lot of data that we might not necessarily need. All right, we've got just maybe too much data. So sometimes we need to sort of build custom APIs to these web pages. Again, it may sound scary, but in reality, it actually is very, very easy. So what we're going to do now is go to one of my favourite subjects in the world, and that's football. I've got 2 main loves, football and music. But don't tell my girlfriend or mum that, because they'll kill me. So we're going to be lifting up all of this data here, and I'm going to show you how we can transfer it from this table into your My Data page, and then we're going to look at making it into a nice graph. And you can do this in roughly 3 minutes, roughly. So what we do first is copy the URL and head over to our browser or desktop application. This can be downloaded from import.io, our web page, and it should take about 5 minutes to download based on your internet connection. But once you've got it, everything is free. So all of the tools that I'm showing you today are completely free. All of the functionality is completely free, so it doesn't cost a penny. So because our data sits in a single web page, such as this one, if you remember in my slideshow, I said that we have an extractor tool, and that allows us to get data from a single web page. So if we just click on the new drop-down menu and click on Extractor New, I must point out now, import aren't very good at naming things, and it's sort of like a common feature in our company. So apologies.
You're at the right place. This is the LSE where this is the new academic building, but there's a newer one up the road.
Oh, really?
So we're not very good at naming things either. And there is a new building which is about to be torn down.
Brilliant. I'm in good company then.
We understand your pain.
So we've navigated to the web page, and it all looks good. It looks really good. We can use this as a normal web browser. We can click on Chelsea and go and look at the Chelsea page. Why you want to do that, I don't know. But you see what I mean. It's a normal web browser. If we were to click on the off button and toggle that on, we're entering data extraction mode, which sounds more scary than it actually is. It's not scary at all. What this then allows us to do is map on the web page whereabouts the data points are that we want to lift. In this instance, it's going to be all of this table here. And it will structure all of these data points into a table, and it will lift it from the web page. So I mentioned before it's point and click. You can see that there's like a little orange box around each of the individual data points. To lift it off, you simply click on it. You tell it how many rows there will be in your table. In this instance, there's going to be many, many rows because there's a row here, row here, row here, row here, and so on and so forth. So you click many rows, and in about 2 seconds, it lifts all of the data from the web page here, and it's popped it into our table up here. So we can keep on customizing it. We can call this team, and we'll just change that to text. And we can add as many columns as we want. So let's say we want to get the amount of points that each team has scored. We then click on the points. And there we go. We've got the data from the web page into the data set. And it's really, really simple. We can get some more stuff such as goal difference. Let's lift that off now quickly. And so on and so forth. And you can do this for however many columns you want. And you can just keep on going and keep on going and keep on going until you're half content. Let's get a few more columns just so it looks good at the end. So we'll get how many wins that we've got. And as you can see, it really is just a case of putting your column titles in and then just clicking on the bit of data that you need. It's really, really simple. So a few things to talk about now real quick is that we run JavaScript disabled. That's a default setting that we have. It's just to decrease the processing time of each page. JavaScript can be quite greedy when it comes to processing time. You can obviously enable it by clicking on the JS button in the top. And we can also turn on and off the CSS as well by clicking on that button. This just gives you the raw data, so it takes off all the styling. So you can see if I scroll down to the bottom here, it's not very aesthetically pleasing, but you can get the raw data, and some people prefer that. By the way, again, for those who are sort of slightly more technical and stuff, we've got, like, you can put custom XPaths in, and you can use regular expression and stuff like that. And you can do some really cool stuff with XPaths. An XPath is just like a path to the certain part of the HTML, basically. I will send you guys lots of resources after this, but you can write custom XPaths and so on and so forth. So, cool. So that's how easy it is to get the data from the web page. If you click on Done and just name it tables or something like that, it's now going to check everything over and publish an API to that web page. So I said before that when the data changes on the web page, it will also change in your dataset page. So here. Obviously, if I refresh this now, nothing's going to change. It's the Premier League, and we've got to wait until Saturday. But if I was to refresh that on Monday, then those figures will change, and we don't need to do anything. Let's talk about this page for a few seconds. We've got a few integration options, so you can integrate this straight into Google Sheets or Excel, which means you can get live data into a Google Sheet and live data into an Excel file or something like that. But we also have a cool feature here called Plotly. Plotly is a data visualization company, and we now have a really cool direct integration into Plotly. So all you need to do is choose the columns that you want. This is really, really super cool. I love this feature. And then it will load for a bit based on your internet connection. I think mine's going a little bit slow now, so you can give that a few seconds. But this will allow you to get the data into a nice table. So if you want to visualize, I've got a 502 error. And in typical IT help, if it doesn't work, try it again. If it doesn't work, turn it off and try it again. And if it doesn't work, then just leave it. And come back to it at the end. But I will try and get back to that towards the end. So we've got lots of integration options. Then we also if we open it into our dataset page, we also have lots of download options. So you were talking about earlier the download HTML and get a HTML snippet and stuff like that. You can download the HTML of the page as well that you've extracted, download it as Excel and JSON and a CSV. And if you have lots of budding data fans, I don't know, on your Facebook page, you can share it on all your social medias and stuff like that if you want to. And there's also an integrate option there. This allows you, if you're sort of coding in Python, whatever, you can integrate this data set and that will be live as well if you integrate it into your client libraries. This page usually takes a long time to load up. I think it takes about 30 seconds to load up. Why, I have no idea. It just looks like a page to me, but we'll come back to that. Here we go. So here's all of our client libraries here. Again, you have the Google Sheets integration there and the Excel. And to get it into Google Sheets, it's really, really simple. You just have to enter your password there and then copy that snippet there. And if we paste that into a Google Sheet, this is super easy to do. You can then obviously have all that data live in your Google Sheets, and you can do some really cool stuff with it in the Google Sheet itself. So let's just whack that in there, and just paste that there, and hopefully in 2 seconds, there you go. So we've got all the data into Google Sheets as well. So that's very, very handy. Again, not having to code anything. All right, we had to code slightly. We had to put our password in, but that's about it. Cool. So that's a single page. That's really, really cool, but obviously not all of our data sits on a single page. Sometimes it's spread out over tens of thousands of pages. And if you have all this, you're probably not going to know the URLs. You might know the URLs, in that case it's fine, just paste them into our extractor and get a list of them. But sometimes it's spread out over so many websites, and the URL is so crazy, like this one here, it would be impossible to generate your own URLs. I mean, that is a crazy URL. So to do this, you've got to use our crawler tool. And I really want to show you our crawler tool because it's our flagship tool. It's the tool that everyone uses basically, and definitely our most popular tool. And I said at the start that it's an exploratory tool. So you don't need to give it all of the URLs for it to go and visit. It generates its own URL pattern. And again, that's something we'll look at the end of this section of training. And it uses this URL pattern to extract data. Again, that might mean nothing to you guys, but I'm sure in 5 minutes you'll understand it and it'll be fine. So, let's just build a crawler really quickly. Let's say we all own a shop, a clothes shop for instance, and we want to get all the prices for all of the items on the ASOS website so we can know how much to sell our jeans for or something like that. We can use import with this. I mean, we could probably send someone around the shop to do it, but there's like 100,000 items on ASOS and I'm pretty sure I'd probably go insane if I had to copy and paste 100 pages. So let's just use import. So this is a slightly different workflow, as you can see, but it's still got the same power. So what you have to do first is detect the optimal settings. That's what I've done there. Again, JavaScript is disabled on this particular page. Again, we don't really need it, so there's no point in having it. And this instance, it'll be a single page. Okay. Before I asked if there's going to be multiple rows or single rows. There's just one result on this page. It's a product page, so it's going to be a single page. If there was many, many results, such as the search result, for instance, this, that would be a multiple row page. There's many, many results. For now, it's just a single page. And then, again, like the old workflow, it's just a case of clicking about where the data is, adding a column and naming it. We'll name this column name. And there you go. We've got the data from the web page into your API. So let's add another column and let's get the all-important price. And then you can also change the column type. So if it's a currency, simply click on currency, and then it will convert this all to a standardized currency. So it's recognized the pound mark here, and it's converted to GBP there. And let's add one more column. And we also have the ability to get the image as well. So by changing the column type to image, click on done, and then just click on the image and click train. You can see that we've also lifted the image. It's worth pointing out now that we don't actually download the image, we use the image URL to render the image itself, so none of these images get downloaded. So it's as easy as that to get the data that you need. Simply click on I've got what I need. And then because we need to train the crawler to get this URL template that I mentioned at the start of the training, we need to give it 5 more similar web pages. But this bit goes pretty quickly, so don't worry about it, guys. I'm super fast with this bit. Again, we can add another page. We've navigated to the page, and we can click on I'm there. And you don't actually need to do any more training at all. You don't need to click on wherever the data is, because it remembers from the last extraction whereabouts on the page the data is. So it's just a case of saying if it's good or not. It's basically just doing a little bit of QA on the pages. And then just add another page. We are looking to get this down to 2 pages, because that would be perfect. Eventually we'll be able to do it in 1 page, but for now we need to give it 5 pages. But don't worry, coming soon. Crawler 2.0. So again, we're just copying and pasting these URLs, and we're just popping them into the top, making sure that all of our data is in our data set, and then we're going to be able to run the crawler. And I'll show you guys what these URL templates are that I've been going on about for ages, which will all make perfect sense in roughly 30 seconds. So we'll just add 1 more page, and voila, add another page, click on I'm there, make sure that the data is all correct. It'll be absolutely fine. It's also worth pointing out that you can still train other parts of the page at this point. So if you found out that you wanted to get the maker, for instance, you can still add a column here. So you can still get all of this data. You can still add data at this point. This is not the be-all to end-all. So we've got our 5 pages. Brilliant. Let's show you these URL patterns, and hopefully you'll know what the hell I'm on about. So we'll just name it ASOS. It just does all of its uploads, and it checks to make sure that the processing time is within the interval, and we get to run the crawler. So, URL templates. What are they? What it does, it looks at the 5 URLs that you gave it, and it looks for variables and non-variables in the URL. So if you can see, the top 3 URLs have the word ASOS between those 2 slashes, and then the bottom one has the word Levi's. This is obviously a non-variable. This is obviously a variable because it changes throughout the URLs. So when we come down here to our URL template, you can see that it's actually used alpha because it's noticed that it's a variable and it's substituted it with a URL template. If we look at the www.asos, that's obviously a non-variable because it's the domain, and it's in all 4 of the URLs. It's recognised this as a non-variable, so it just leaves it. So basically, all of the variables get substituted with this URL template in the squiggly brackets. Now, the cool thing about this is that we can actually put in non-variables. We can put in terms that we want to be a non-variable. So what you can do is you can put in the term jeans, and then let's add another URL template at the end. And this creates jeans as a non-variable. So it will only extract data from a URL that has the word jeans in because it's a non-variable. So that's really, really powerful, and you can really hone your URLs to get certain parts of the website. So we're just going to set that back to defaults because we want to get all of the products. And then all you need to do is simply click on Go. And because we've given it a lot of training, it should actually go to most of the pages that we want it to. In fact, it will go to all of the pages that we want it to in this instance. You don't need to change anything in those advanced settings. I just wanted to show you guys what the URL templates and URL patterns were. What you can just do is hit Go, and we'll just give it a few seconds until it starts bringing in data. Again, this is quite dependent on internet connection. If you've got a slow one, it will run slower. But we're getting 1,600 pages per hour, which is pretty good. And you can see it's got the ones that we've got so far. And then in a few seconds, it's just going to go mad and just bring back loads and loads and loads of results. So I let this go for an hour, and it should bring us back about 6,000 pages of data. So it's pretty good.
How does it work exactly? Is it based on Google index pages, or does it randomly look for URLs?
Really good question.
Probably just follow the graph.
The way the crawler moves around the website is that it visits every single link on a page. So it'll visit this link here, and then if this URL at the top matches the URL template that I said at the start, it will extract data from it. If it doesn't, it will put it to one side and forget about it. But yeah, that's how our crawler navigates around web pages. It goes for the links.
And ASOS is cool with it because you're following their robots.
Yeah, we follow the robots.txt protocol. So if they recognise our crawler bot and they don't like it, then we just say that's fine. It usually happens with Facebook pages. They don't like us for some reason, but hey, So let's just leave that running for a sec, and let me just show you the connector tool. I'm not going to be able to demonstrate building one, but I can show you the general idea of it. And we can do that by, in true sort of daytime TV celebrity chef style, here's one I made earlier. If we look at the Tesco connector, I made a connector up to Tesco, and I mentioned before that if you're searching Tesco for the price of bread, for instance, you don't actually have to go to the web page to extract that data. So you can see here on the left-hand side we have query boxes. We can change this query to whatever we want. We can get the price of cheese, and what this is doing is it's going to the Tesco website, hitting the, putting cheese into the search box on the Tesco website, looking at the results from that search and extracting those results and popping it back in the dataset page. So we can make this cheese, we can make this chocolate or something like that. Again, it will do exactly the same thing, and you have the prices for chocolate there. So it's a really, really powerful tool for getting specific bits of data. We have a lot of price comparison clients that want to query lots of URLs for a specific SKU or a product number, so on and so forth. So they just make loads and loads of connectors up all day, and they can do that from a single query box. And it's really, really powerful stuff for getting pricing data. So let's just go back to the crawler to finish, and you can see here it's starting to go a bit crazy, and it's got lots and lots of data now. So we're at, unfortunately my screen's a little bit skewed, so I can't actually see how many how many pages have been converted to data. But yeah, there'll be hundreds of there, and you can leave that going. It's all done local on your machine, so your machine obviously has to be on for it to work. But yeah, you can let that run, and it's queued up 39,000 pages already, so there could be a hefty amount in a few hours. And that's basically import in half an hour. I hope you enjoyed it.
Thank you very much.
We're doing questions. Questions at the end, are they? Or if anyone has any now, then.
Yeah, if somebody has right now, then we can have one or two now. Paul, what is your, how busy are you in terms of time?
I put about 15 minutes, 20 minutes.
Okay, then maybe it's actually better than if you just continue. Yeah.
Cool. I'll give you the VGA cable. Not too sure where that went.
It's in. It's right
It's
there.
there, is it? Oh, okay.
It's right there.
It's hiding from you.
Yeah.
There you go.
Well, thanks very much. That was really interesting. You did say at the start that you were going to be interactive and not bore people to death by talking about data scraping for half an hour. So I guess that can be my job. So I'll try not to make it too dull. Just to say who I am, I work in methodology as a research officer on a project where we make tools for analysing text quantitatively, so statistical word frequency analysis. My background is in computer science, not in social science methodology, so I focus more on the technical challenges, but I'll say a little bit about some of the methodology issues as well. Just to step back a bit and think, why do we need to do data scraping in the first place? Well, the fundamental cause of that is that websites display information in a way that's supposed to be easy for humans to read. We need to work with the data in a computer program, maybe like Stata or R. So we need to transform the information from human readable to machine readable formats. So humans read English, machines read JSON or XML or CSV. And the internet browser is the tool that converts the human readable format into a nice display that you can view on your internet browser. But it's not much good for running through social science data analytics programs. So why is the data available and public but not machine readable? Well, there's a few reasons why companies might not make their data available in a machine readable format. Probably the most common one is that they have a lack of resources. The most important thing to them is that their customers can read their data easily, so they prioritize human readability. They might not be aware that there's a demand for other companies or academic researchers to have the data in a structured format. And finally, there might be a conflict of interest. So I've come across a few cases where, for example, a government agency might be legally obliged to make data available, but they're not necessarily obliged to put a lot of effort into making it easy to work with.
So the same would apply to in a corporate environment. I know Ryanair are very unhappy with the comparison website Skyscanner, so they're trying to stop them from doing this kind of thing, and that conflict of interest can lead to them deliberately making it difficult to work with the data in that way. Okay, so as I said already, when we want to do social science data analysis, we probably want to end up with a matrix where we have some independent variables in columns and a dependent variable. And with the public data we have, at best we have HTML. As websites become more and more complicated, you've got JavaScript, as you showed, you've got CSS, and we want back a nice CSV file, or maybe JSON, depending if we need some sort of hierarchical structure in the data. And scraping tools, as you showed, bridge the gap. So some tools I was already aware of. If you know how to program in Python, there are libraries to help you do this. ScrapePy and Beautiful Soup are two popular ones. In R, there's one called RBest. As you said, even if you can program, I've done a lot of this, and it's some of the most frustrating, nitpicky, awkward computer programming you can ever do. It's no fun at all, and tools like this make it a lot easier. There's a Chrome plugin that does some of this, but it's not as advanced as stuff that you should. Some of the ethical, legal, and privacy issues around working with this kind of data. So one issue is who owns the data? Is there a copyright? And in general, how happy are the organization that produced the data with other parties taking it, reposting it or analyzing it? There's often a lot of legal text involved at this point. Somebody already mentioned there are certain internet conventions. They're not really legally binding, but they're advisory, like robots.txt, which where in the HTML code of the web page, the company can specify whether they're happy with automated programs scraping their data. And if they're not happy with you, they will try to detect automatic scraping of the site, and they can either impose limits on the number of requests from a particular IP or block the IP altogether. There's also one thing that's useful to be aware of if you're coding these tools yourself is when your browser accesses a website, it sends a piece of information to the website called the user agent string. The user agent string tells the browser who you are, but that can be changed, that can be specified by the person sending the request. So you can sort of spoof these to make it look like you're not a robot. There's a lot of interest in social science and working with social media data. So that introduces another set of ethical problems. I've heard people talk about it in terms of a conflict between, do you see it as an issue of personal responsibility? It's the user's responsibility to read the gigantic licensing agreement, and if you use a service like Twitter, they're quite clear that everything you post on Twitter is completely public, apart from the direct messages. Or do you have a reasonable expectation of privacy if you feel that you're only communicating to your followers? And there's one sort of slightly tangential point I'm going to just mention, which is the difficulty of anonymizing data in these kind of cases. So a lot of the time the approach people will take to sort of sensitive data is they'll use the data but remove any information that can map records directly back to individuals. But this is a very difficult process and unreliable. There's an interesting case where somebody in the US, I think it was an academic, wanted to study New York taxi cabs. So they put in a Freedom of Information request for the logs that the machines make, and they gave them the information, but they obfuscated the uniquely identifying aspects of it, the medallion numbers and the cab numbers. And the way they do this is they use an algorithm to change the number to a different number, and supposedly it's called a hash, and it shouldn't be possible to reverse this process, but they didn't use a good hash, and there were only 22 million different possibilities, and you can compute them all really easily. There's also another example people found in this was that they could identify things like Islamic cab drivers because they all stopped driving at certain times to pray. And if you have you can cross-reference the public information like pictures of celebrities at certain locations. You map it back to the location of the taxi. So it's not as simple as just blocking out the name or changing the names.
Four data points can de-anonymize most. That was academic research that showed if you have 4 independent data points, you can almost certainly de-anonymize the data set.
I guess probably it's pretty exponential. The more you have, the more you can figure out. If you want to see more of that, it was actually a blog post on the LSE blog. It's interesting. Okay, so back to issues about data scraping. In addition to the ethical problems, there are issues that affect the quality or the reliability of the conclusions of the research. So if you're scraping data from a public source or a web source, you don't have complete information about the origin of that data in the same way you would if you collected it yourself through a survey, for example. And also, there's a lot of emphasis in modern sort of database research that your research should be reproducible. So you must be able to share your data, and other researchers should be able to check it by using your code. Obviously, that's a difficulty if you don't own the data, and also if the data changes a lot. So for my PhD, I worked on an experiment where we needed to estimate frequencies of rare phrases in English. And researchers in the area were using the number of hits returned by a Google search to estimate the frequencies of the phrases in English, because you just won't find some of the phrases in a small corpus. The problem with that is that those frequencies changed all the time, and we don't know why they're changing. We don't know if Google's changing its algorithm, so it's impossible to reproduce it. And we don't know the motives of the people hosting the data. Sometimes we don't know, do they manipulate the data before they make it available? And there's obviously the usual sampling bias errors, like simply if you do social science or sociology on Twitter users, that's a certain segment of the population, skewed segment. I'm going to finish up with sort of a plea that if any of you are ever in the position of having to make data available, please make it machine readable. So we can avoid this problem in the first place if you just take a few simple steps. So governments are becoming really much more aware of this. If you go to either of these two sites, data.gov.uk or data.gov, that's the UK or the American, US open data websites, and they have really, really impressive, they're taking great strides to make data available in lots of formats. So I was amazed, I just checked it today on the US site. You could download data from lots of different agencies, and it was available in all kinds of forms: CSV, JSON, Excel, everything that you want. And often it can be made available in both forms, so you've got a nice, easy to navigate, pretty looking web page, and also you've got the raw data as a download as well, which makes it really easy for researchers. And I think this is really important as well. It's very important, this doesn't just apply to scraping, but to ordinary data collection, to consider machine readability at the time when you collect the data. So I was working on a project with somebody in methodology who wanted to analyse a type of court hearing. It was appeals for asylum. And the researcher I was working with wanted to know what was the association between the verdicts and the things like other variables like the nationality of the applicant, the judge, the party who selected the judge, all these other variables. We had 20,000 records of court cases, but they were just in plain text files that had been typed up by somebody. And one person would write like judge and then the name of the judge, and then the other person would use a slightly different phrasing like presided over by or whatever. And that makes it impossible to extract the data in a nice tabular format unless you spend a lot of time, as you said, writing regular expressions. So you can save, and especially government agencies could save researchers a whole lot of trouble if they consider the need for a tabular format for data at that stage. Oh yeah, maybe I should have said this earlier. Another way that people can make it easier to get at data without web scraping is to provide an API. So you're saying that provide an API which imports things in real time. I mean this more in the context of if you're using a computer program, some websites like Twitter, they provide a service whereby your Python script or your R script can directly connect to their information in a sort of structured format that will return JSON. So this means that it sort of shows that the data host is encouraging people to use their data in a programmatic way. But these types of APIs I'm talking about, you would need to know a little bit of Python or something, but that's not the case in I think what I was describing. Okay, just to say, I had a little look at the import.io site and what I was going to say, and I think it's really, really, really useful, and it's completely different from the things that are already out there. And during the talk, I think especially the URL crawler, that's not available. I mean, that's really, really vital. Because there's no easy way to discover the structure of the URL.
Well, I think there are lots of crawlers around. They've been around for 20 years, but the problem is that once you crawl, you then have to do all the work of organizing. So the combination of the organization and the crawler, because I mean, you can easily find out there are some tools that have crawlers built in, but they are not then helping you organize it afterwards. So I think the combination of those two, I think, is really
absolutely, yeah. And the structures, the URL structures, are so unpredictable that it's a difficult task. And it gives a nice continuum between simple and complex approaches depending on what you need to do. The sort of interactive training bit is vital for, especially more and more web pages are not just simple static pages, they've got so much JavaScript and interactive stuff. That's absolutely essential. And I think I saw something on this website about a cloud platform as well. I don't know. So it means it can scale up very easily. And obviously it means, above all, you don't need to write a custom program. Okay, so that's all I've got.
Questions?
So what do you normally do after you scrape the data? Is it you download CSV, then would you run it through some statistical software?
Yeah, it depends what kind of analysis. I guess for the example I gave with the asylum cases, they wanted to have a CSV or something that could go into, for example, this data where the dependent variable was the verdict and the independent variables were things like the judge and the nationality of the asylum seeker.
So in the same example, because there were documents there, so did you end up actually going off the project or say we cannot do it, or there was any what were the strategies when the wording can be quite different to refer to the very same subject?
Yeah, well, what we did was I sort of got involved because I could do the Python regular expression scripting. So the researcher got a couple of research assistants to look at the different phrasings that were used in different pages, and we made some, long awkward scripts with lots of if statements in them, and then checked the results, and eventually we got as close to it.
Another question, perhaps the two, I don't know if you can have a joint question. So when you extract this data from the web pages, can you look for associations of words or as well? Or I see you extract as columns, and it's very handy for when you treat variables and you don't have dependent variables, you can model them. But in terms of associations, some sort of map how certain words are used, for example, in a text, which is a completely different technique. But I was wondering if the ability to extract data could somehow be useful for this kind of analysis. So
There's probably qualitative text analysis software that you can run this stuff through.
No, it could also be quantitative.
Yeah.
Just
Yeah.
do lexicographic analysis of the text. But I assume, is there any technical limits to how many bytes you can have in a field?
Sorry.
Is there any technical limits to how many bytes you can have in one of your fields? So what if I have I want to scrape off where each row, there is one of the cells in the row would have whatever free text was in there. That could be like a 10-page textual document.
Yeah. Very good question. In each cell, you can pretty much, so long as it's in the same sort of page HTML, it doesn't really matter how big it is.
Okay.
So I wish I could show you a decent example. Like descriptions are a really good example of this. If you have sort of like a cell with, I don't know, some sciencey thing in it, and then a nice big description, you can get that description quite easily. Yeah. There's no limit to the cells at all.
Because I think in the social science context, a lot of the examples would probably involve textual analysis of some sort. I was just wondering, in your set of tools, have you got good examples where people have done that, where it's not only like one data item here and then the next data item here, and then you have a lot of row of those, but where it's also you are scraping off larger chunks and you want to do some text analysis of those chunks?
Yeah, I could show you a very simple case of that. Again, this is probably the simplest way I could probably share it to you in my own experience, but it's sort of, it might not be analysis sort of thing. We had this massive thing, massive sort of game we played, and we started to make word clouds up. And obviously for word clouds you need a hell of a lot of text.
Yeah.
So we decided to go to all of our blogs and all of our partner blogs. So we went to blog.import.io and we crawled all of these blog posts here, but more importantly all of the text here.
Yeah.
So all of this text here sat in one single cell in the
well, exactly, something like that.
And you could get, all of this text into one cell as well.
Yeah.
And the fact we can write custom XPaths as well meant that we could just put like a H1 tag in or something like that, and it would just get the headers and then just P tags and just get it all. Yeah. So there's no limit to extract as much as possible.
Would it scrape the entire blog post or only the bit that's visible on this page?
So if you used a crawler, then you could get all of the blogs. If you use an extractor, that's obviously a single page. So what we did is we just ran a crawler to our own blog. We were a bit worried about it. We might get a bit like Inception, and it was sort of like just get the blog and then go round and go round. But it was fine. Yeah, we got all the text, and it was really nice, easy way to get the data actually.
Just wanted to ask. I saw one of your examples. You had it was the jeans example, and you had jeans by ASOS and jeans by Levi. And it looked like you were using the word "by" to detect the boundary between the word jeans and the maker. So does it use, in some cases, does it use the text to delimit, fields?
Yeah, again, really good question. It doesn't actually use that, but by using something like the XPath override feature that we have, you can do like a search anywhere on the page, like full stop, / star, square bracket equals in inverted commas by, and then get like following sibling or something like that. So in that instance, you can hone it to a certain word on the web page, and that's quite a common use case actually. If there's one thing we struggle with, it's when text moves around the pages quite a lot. So if we to look at these ASA models really quickly, this would take 2 seconds to demonstrate hopefully. And if I just go to where's the data sheet? There's the data sheet. If we go to the data sheets of these 2 laptops, you can see that in the just underneath memory, we have maximum memory, then memory technology in these rows here, and then it's memory technology and memory card reader. So they're actually in different rows. Okay. So obviously it will get memory card reader for memory technology.
Yes.
What you can do is you can write an XPath to look at just memory technology on that page, so it will just look for that.
Just search for that term.
Yeah, that's completely it. In fact, I think I have one. Where are we here? Yeah, look, something like this. Just uses that little XPath protocol there, the full stop equals screen size, and it'll just look for that piece of text on the page and then get the following siblings. So that's not how the default XPaths work, but that's an example of how you can sort of override that sort of stuff.
Have you got any, so is there any tips and tricks that we could use on direct integration between your platform and then sort of computational linguistic tools, like for textual analysis tools?
Yeah, I'm just trying to think of a few text analysis tools I've used in the past, and I mean, it's not really my cup of tea, really. I don't really do that sort of stuff, but I guess because the download options are pretty
So you
pretty standard.
You would be the gateway,
Yeah, completely. If you're just using it for static data, then just use one of the Excel, CSV, HTML, JSON. Probably CSV would probably be easiest, or Excel for that sort of stuff. Because obviously most text analysis is obviously using static data. You're not really using it for dynamic data. So yeah, that's probably the best way to do it.
I have a question. When you query data, can you append the information to the, if you go to the same web page, let's say you go every day at 2 o'clock, so can you append the data so that you would get the longitudinal data?
So do you mean like scheduling the queries?
Yeah, so that it wouldn't just replace the data set, whatever you have there, but it would be built on top of that and get you there.
Yeah, completely. So whenever you run a query, we take a snapshot of that query.
Yeah.
So if I was to press the query button here, it is possible that you can get that particular query there as a snapshot, and then you can open up that snapshot and get that data, and then when you run it again, it will take another snapshot, and so on and so forth. In terms of automatic scheduling, I can say that that's our next feature that's coming soon. So you won't have to do that. You won't have to open up your computer every morning at 6 o'clock. query. You can just set like a simple schedule, and again, that you won't need any coding for that. You can just set the time limit, and that.
You can imagine conditional scheduling as well. So you say poll it every morning, but if the result has not changed, don't bother.
Yes, that's. I mean, it would have to run to see if the result has changed.
No. I'm just thinking if you could take this like a Turing equivalent sequence selection and iteration, you can say combining those, because I imagine the price comparison use of it is exactly poll it as often as possible, but if it hasn't changed, don't do anything. Send me a message if it has.
Yeah, completely.
Or update the data.
So there's another tool anyway that's called if this then that. So you can.
I know, I use it. So now all my Facebook postings get tweeted as well. I don't know how to stop it.
We're actually looking at a direct integration with if. That would be very, very handy.
It'd be very handy,
and email notifications is something that a lot of people have wanted. Me especially. I'd love to have notifications when my data gets changed. It'd be good.
So future research will write itself.
Yes. If then PhD dissertation. Excellent.
I think it's an interesting question for us how to use this to combine with our research.
Well, I mean, you see, the latest paper we got published, we basically did it all manually. So we looked at Ben, he had just under 6,000 blog posts, and we just all did it manually and put it into spreadsheets. But we've tried for the next paper we're doing, we've just very fooled around with it, and of course it is much easier. Yeah. So that was the reason why I suggested we should have it.
We have a pretty good support team as well, so if it goes wrong, just email those guys and they'll be able to help. That's great.
Thank you so much.
Thank you very much for having us.
Okay. Before I actually let you guys go, then just since the Easter is coming and everything, in that spirit, thank you for coming.
There you go.
Thank you very much. Wow.
Thank you very much.
There's a gift card to the dentist.
It's all integrated.
Paid by the department. I didn't have money for that. So. Anyway, once more. Thank you very much.